be offloaded to the main processor. But let me just kind of show you guys what the Kinect is. Okay, Kinect from Microsoft. You can look for video clips. There are some really interesting video clips that you can find with the Kinect. And one of those, okay, I'll look for Kinect and then the word hack. This one I haven't seen before, so we'll. Here's the Apple.
It's sort of like an interactive live puppeteering tool that tracks the silhouette of your arm and then uses that to control a kind of digital puppet. And yeah. So when you open your hand, it sees the points of your hand and opens his mouth and...
Okay, we'll try this one instead. This one is...
So, I got my Kinect. Here's the box. And I decided, after all the cool stuff that others have been doing with it, and the fact that now it's more or less hacked, that people have figured out how to move this.
Okay, so at this point you would think that, oh, this must be a bad video feed because, there's a kind of like a shadowy artifact, behind the guy, right? I mean, it's not an effect. This is actually when we pan around and rotate, you will see what is actually going on with this little demonstration. It's really quite impressive.
So they have figured out how to actually get the color images and the depth images out of it. I decided I would try to use the depth image and the color image and put them together, and then project the image back out into space in order to recreate the original three-dimensional objects that were captured by the cameras in their original position, orientation, and size. So what you're looking at here right now is not just a video, but it's actually the 3D reconstruction. And right now I'm showing it from the point of view of the camera. But if I zoom out here a little bit and move it around, I can move the image around in 3 dimensions. And you can see that the objects in there is myself and there's my...
Okay, so here is the interesting part, because what you just saw was not an actual video feed. It was actually a 3D map that has the texture mapped on it. Okay, and that's because the Kinect device is not just like a Wii. A Wii works in a different way. A Wii, when you use the accurate mode, what it does is, it will see the light from the light bar itself, and then by analyzing, how the two dots of the light bar, changes, the distance between them and changes, orientation. From the Wii remote's perspective, they can kind of tell, where you're pointing it, whether you're getting closer or further away from the Wii. This one is different. The Kinect device has 2 cameras, okay, to give it quote unquote stereo vision, and that's what it does. That's what it does to. Plus an IR emitter. They have a certain IR emitter that emits a certain pattern onto, it will project a pattern of IR beam that you cannot see onto, to the front. And then the 2 cameras will analyze the reflection of those IR points, and then analyze and figure out, okay, this point is at this distance, this point is at this distance, this point is at this distance. So what you're seeing here is, so basically, the Kinect device would actually just capture. It will capture a 3D profile of what is in front of it. Okay, which is kind of equivalent of if I shoot out, laser beams, from this origin, I can create a profile of, the distance of every single point that is in front of me with a certain, view angle. Okay, and that's what the Kinect can capture. Okay, with a certain resolution. Some people claim the resolution is good for even pointing out a finger. Okay, so if you try to point out a finger in front of the Kinect, it can actually pick out the finger that you're pointing out. Okay, now so that would give you a 3D a 3D wire image without the actual image. So what this guy has done is also to use the video feed to map the texture of the video feed back onto the 3D model that the Kinect is capturing. Okay, So that's really quite amazing, of what people can do with the Kinect. If I show a little bit more, you will see a little better.
Teacup right here, that they are actually reconstructed in three-dimensional space. So we have a really true, almost holographic camera image. Of course, you see that.
Now this is also a very good image because it shows that the Kinect device is probably somewhere over here because you can see the shadow of the guy because the Kinect can only see the front object. It cannot see anything that's behind him. So therefore, there's a little shadow that is casted behind the guy from the Kinect's perspective. Okay.
Since the camera only looks from one point of view, there's a big shadow behind me right here.
Okay, so now he sees
and if you look at me from the other side, there's no back to my head because, well, the camera can't see that. But apart from that, that's what my room looks like here. So the idea is that based on the fact that we have a depth camera, we can really do this 3D stuff and you can use it for all kinds of purposes. Alright, and there's more to come, so I'm going to try next to see if I can use the 3D images and put them into another 3D environment in order to mix realistic people captured with the Kinect with the computer-generated imagery, but I'm not quite done with it yet. So.
Yep, so I think that is actually pretty impressive, okay, because welcome back. So this is actually quite impressive because the Kinect device is actually only $150. Now you would say $150 is a lot of money, but if you go to, let's say, the Department of Defense and ask, how much would you pay for a device like this? They will probably spell out, something in the millions range, especially when it is a prototype. Okay, so this is actually quite amazing, of what they can do with $150. I mean, that's like dirt cheap, compared to the type of technology that you're getting from the Kinect device. Now, the reason I mention this is because the Kinect device also has 4 microphone elements. In other words, it can actually do the DSP or digital signal processing. So when you're playing a game, the whole idea of the Kinect is you don't have to wear anything, you don't have to hold anything to play your games. So when you're playing with, when you're playing a game with the Kinect, supposedly, Microsoft wants people to be able to chat, audioly, with other players without having to put on a headset. Okay, but that can be difficult because the room itself can be noisy, right? So what they do is they're trying to use the 4 microphones to do the digital signal processing to locate exactly where the speaker or the player is in the room, in that space, and then just do the signal processing to isolate the sound coming from that spot and suppress the noises from everywhere else in the room. And that technology is already here. If you go to a lecture hall, they have also multiple microphones, and they have the software to do exactly that. They can basically use the triangulation method to locate where the speaker is, and then they can isolate the speaker from the surrounding, so the recording or the projection on the speaker can focus on just the person who's talking and not the noise around him or her. So in this case, you have a $150 device that can do that, and I personally think this is actually quite impressive. And what is kind of related to this class is what people have done with the Kinect. Most people would just buy a Kinect, hook it up to a PSP, Xbox 360, and call it a day. But there are people who are curious about how this works and how to make it do their work instead of what Microsoft wants you to use it for. So if you look under hack, there are multiple people multiple people have hacked the Kinect, and I think one of these, let's see, Shadow Puppets denies. I can't find it right now. Oh, I know where to find it. I can find it from my own email. The reason why I even know about this is not because I have an Xbox 360 It's because some of the students in the CIS club, called the Arc Dev Club, has been mentioning this and asked me, do you know anything about this? No, not really. What is it? And they pointed me to a particular website. Let's see here. Oh, this is interesting too, the cheating part. But let me find the other one. I might have deleted it, fortunately. Oh, there you go. So this is basically a close-up of what the 360 looks like. And here is an article on how someone or a particular team has hacked and reverse engineered the USB protocol used by the Kinect to talk to an Xbox 360. Okay, so let me just kind of describe briefly what these people have done and why I think it is related to this class. These people bought a Xbox 360 Kinect. Okay, they're impressed by what it can do, but they want the Kinect to be used for other things because it is just a USB device for the most part. So what they have done is they have used software and hardware tools, okay, if I just kind of skip here, to get the information out of the USB traffic. And they use very specific software. Let's see here. I'm just trying to find the right portion here. Okay, here they go. They basically use a USB bus sniffer to sniff out the traffic that is going on between the Kinect device and the PC. And they try to do different things to try to analyze how that changes the stream of data coming back from the Kinect. So in the end, what they actually successfully did was they were able to find out the protocol enough to utilize the Kinect for applications that Microsoft did not intend. Okay, they were able to talk to the device and figure out how to use the device by just reverse engineering based on the USB protocol. So I just think that's kind of impressive, of what they can do. And this class is not quite there, okay, not quite at that level. This is the kind of stuff that you can do after you get your bachelor's degree. Okay, for the most part, for most people, because it does involve a lot of analytical skills and other stuff that you need when you write programs. But some of our students here at ARC are already thinking about making the Kinect to work with their own programs. So I'm just kind of curious of what they're planning to do with it, and and it's kind of exciting. One application of the Kinect is robotics. Think about it. How does a robot see what is in front of it? Whether there's an obstacle, what kind of an obstacle is it, and so on and so forth. It's not that easy. Okay, most robots have very simple-minded sensors, like an ultrasound sensor. An ultrasound sensor is basically just pinging what is in front or in a certain direction of the robot. By analyzing the delay between the pulse and the echo of the pulse, they can figure out the range of the object that is reflecting that pulse of ultrasound. But the ultrasound sensors that we have are not really accurate. Okay, they cannot pick up small objects. In other words, from a long distance, this object cannot be picked up because it's too small. The reflected pulse is not strong enough for the sensor to pick up. But the Kinect would be perfect for that type of application. It has a range of about 12 to 13 feet or so, which is good enough for a slower moving indoor robot. So I just personally thought that this is somewhat interesting, and
Dr. Jack,
yep.
could you post that website to our Moodle entry later on, if you don't mind?
Yeah, I can do that. Because if I just keep talking about subroutines, it's